Hello. In this series of finding equation of reciprocal function, let's look into the graph. Here we find that there is a vertical asymptote at x equals to 2. That means the original function should have a 0 at 2, right? So let's try to write down the original function. Let's say this function is f of x and the original function was g of x. In that case, reciprocal function f of x is equals to 1 over g of x, and g of x seems to have a 0 at x equals to 2. So we can write this as x minus 2 whole square. Why positive? I'm taking whole square. See, everything is positive in this graph. Do you see that? So whether you are on right side of 2 or on left side, both sides are positive. That means the whole thing is kind of a square. So we expect this kind of a function as the reciprocal function for whose graph is given to us. Now let's try to test it out. Well, if we see the reciprocal, then g of x should have 0 at 2, right? This is 1 y value, so it has an invariant point, so that seems to be okay. And this seems to be like this is 1 and this is kind of half, and this seems to be 1/4. So approximately we can say this is 4, correct? So here also it seems to be 1/4, so it seems to be like this. Now if we connect these lines, we can draw a parabola, and that parabola is g of x for us. So we have a parabola here, like this, correct? Now let's check the equation of this parabola. This parabola is having 0 at 2, so x minus 2 whole square, because the double 0 at 2 as the thing turns from here, the vertex, and at 1, so we see if you move 1 unit here, then we have step of 1, right? And if you move 1 more unit, then we have how many steps? 1, 2, 3. So the steps are 1, 3 and so on, seems like, right? Therefore a value is also 1, correct? So a value should be 1, and that seems to be the perfect equation for us. So therefore we can write reciprocal function here, f of x, as equals to 1 over x minus 2 whole square. Okay, so I think that should satisfy the condition. Reciprocal means reciprocal of a quadratic function or a linear function. So it looks like reciprocal of a quadratic function, and since both sides are positive, that seems to be a good proposition, and it fits into the description. So that is the reciprocal of our equation of our reciprocal function. Okay, thank you.